I am really excited to be here today to share all the great work that we're doing, and it's not just the service. We are working with the cooperative, like I will get into, which is both with the two state agencies. And so I'm fairly new to the Lake Champlain Fish and Wildlife Office. I'm the supervisory biologist that oversees the fisheries assessment program, and I started in that position about a year and a half ago. But although I'm new to that office and the position, I grew up across the lake, so it's great to be home. I'm happy to be back in the Lake Champlain Basin and working on these items. So first, a quick overview. I'm just going to step you through what I'll be covering today. I'll start with a little background about landlocked Atlantic salmon, which I'm sure you all are slightly aware of or could be aware of, but I'll still provide some information to help get you caught up to why we're doing what we're doing. And then I will share the information, share some work about what the office is doing, what we're focusing on in the fisheries assessment program. And we'll share some early results that really have gotten us to where we're going today and the work that we're doing today. And then I'll give you a little bit of an insight on where we're going in the future. So historically, there is a large population of landlocked Atlantic salmon found throughout the basin, with 8 of the major tributaries supporting salmon runs, with 2 additional tributaries that possibly had occurrences. There are a number of historical accounts of salmon in Lake Champlain, including 500 salmon being taken from the Boquet, which way am I supposed to go? The Boquet River in one afternoon. However, these fish were extirpated from the basin by the mid-1800s. The major factors that contributed to this is habitat fragmentation through the construction of dams, habitat degradation through a variety of land use practices, and overfishing. And so, just to point out, this is a picture I'm sure you're all familiar with in that lower right-hand corner, or maybe I can use the mouse, huh? As well as pointing out that salmon were, part of the history of this area, with salmon actually being represented on the county seal for Clinton County. So salmon's definitely been, important to the culture around the lake, and definitely was a major loss when they were extirpated in the mid-1800s. So the Lake Champlain Fish and Wildlife Management Cooperative was formed with the states of New York in their Department of Environmental Conservation, and then the state of Vermont through their Fish and Wildlife Department, as well as the service. And this cooperative was formed in the 70s because there's a lot of efforts to restore salmon and lake trout, which were also extirpated in the 1800s, back to the lake. We really wanted to get those native salmonids back to the lake, and a variety of strategies were used. But in the 1970s, there was the goal to really restore those 2 populations, or 2 species. And so, although there are a number of native and a handful of non-native species, the cooperative decided it really wanted to, again, focus on the 2 native salmonids, lake trout and Atlantic salmon. But there was a new fish that they had to consider, and that was the sea lamprey. And so they really wanted to focus on suppressing the population of sea lamprey, the invasive sea lamprey, to help establish robust fisheries. So the goal of the cooperative was to develop a sustainable fishery while striving to increase the number of wild fish and reducing the population of sea lamprey. And I do want to emphasize that now, we have a strategic plan that was developed or is actually revisited every 5 to 10 years, and so there's been many iterations of the strategic plan. And the most recent is 2020 to 2025, so we're in the process of actually forming a group to work on that next version. But the 3 primary goals of that strategic plan was to maintain a fishery. And I think that's really important because that emphasizes the fact that we were able to meet some of those early goals back from the 70s to establish a fishery. So now we have a lake fishery, and so our goal is to maintain that fishery. And again, we want to restore self-sustaining populations and continue to suppress sea lamprey. So self-sustaining population is difficult to achieve, and we can't do it with hatchery propagation alone. So the early efforts started with stocking, and we recognized that we weren't getting these self-sustaining populations. We weren't getting fish coming back, at least when it comes to salmon, we weren't getting fish returning to the rivers to spawn. And that's primarily due to a lot of the challenges that caused them to be extirpated to begin with, and a lot of that is driven by habitat. There's lack of passage to habitat where they need to get to spawn. And again, that habitat degradation is a big component as well. even if they were to get to where there was historically quality habitat, was that still quality habitat? Climate change is also a driver, right? Streams are warming, and so areas that were potentially cold water before are warming and potentially not necessarily providing that nursery habitat that it did historically, as well as invasive species. So not only when it comes to sea lamprey, there's issues with other invasive species that are introduced into the system. And one major one was the alewife. So in 2003, the alewife was introduced into the system. That species became more widespread around 2007. And so alewife actually contain an enzyme called thymidase, which it basically breaks down thiamine in fish that consume thymidase. And so thiamine is an essential vitamin. It's vitamin B1, and it's essential to reproduction. And so if we're not getting fish that are able to reproduce, we're not going to be able to achieve that self-sustaining population goal. So thiamine deficiency complex is an issue that has been actually something that was seen in the Baltic Sea back in the early 80s, and something that's been seen in the Great Lakes. Then we started to observe it here, and now even Pacific salmon are dealing with this issue, and it's an emerging threat for Pacific salmon out on the West Coast. So it was recognized that we needed to take an adaptive approach in order to manage for these fish to rebound and reestablish a population. And in 2022, the Fisheries Cooperative established the 2022 River Run Restoration Plan, which helped to highlight goals and provide opportunity for to identify actions that were needed in order to rebuild the self-sustaining population. So, bringing it back to the service and what the service has done, the Lake Champlain Fish and Wildlife Conservation Office has made a contribution to Atlantic salmon restoration over time, and it's evolved over time. So Nick Statz was hired as the Vermont liaison back in 1994, and he assisted with monitoring of salmon, but his focus was primarily on the Winooski River. Then Bill Ardren arrived in 2008, and he brought a suite of skills that allowed the service to contribute to the research, especially in hatchery propagation. And over time, he started to build the program and started to think of strategies to reestablish the population to the basin. So he worked closely with universities, but then started to build a crew. And in 2015, we started to form what we now call our program. And so it's really important to point out the work that these two did, because they definitely helped to build the foundation for what we're doing now. So as the work has evolved and we've created this program, we've been primarily funded by the Great Lakes Fisheries Commission, and so that's really important to point out, because without them, we wouldn't be able to do a lot of the work that we're doing. And it also has provided the opportunity for the 3 programs in the office. So at the Lake Champlain office, we have our sea lamprey control program. We also have our habitat program, which you'll hear from Dave Minkoff here in a bit. And then we also have our 2 national fish hatcheries within Vermont. And so Paul will speak about some work going on at White River later today. So it has provided the ability for us all the 3 programs and the 3 facilities to all work together to achieve the common goal and to deliver the mission of the service in Vermont. So our program has the goal of informing adaptive management decisions related to restoration of native species, primarily landlocked Atlantic salmon, but we're starting to tackle American eel now as well. But we're focused within the Lake Champlain Basin, and we're doing this through applied research, monitoring, and hatchery evaluation. Our primary focus has been on landlocked Atlantic salmon, and we're doing this by working adaptively and cooperatively with our partners, but also with the other FAC programs and stations. So just to highlight our people, because I think it's really important, I'm here, Laurie Earley. I've been here for about a year and a half. Some of you may know Kurt. Kurt Heim has been at the office now for 3.5 years, and he has been really active with the angling community and gathering samples for some of the work that I'll speak to here in a bit. And then we also have seasonals, 2 to 3 seasonals that you may see in the Willsboro area, especially in the fall. But then we also have Brian Ross, who was recently hired as our field crew leader, And we're also in the process of hiring another fish biologist. So we may be a small team, but we are a mighty team. And I just really wanted to point them out. So I think it's important to highlight some of our earlier results and the accomplishments that helped us to get to where we are today. And as I mentioned, okay, we'll jump right into it. Sorry, things are a little different on this computer. But so first off, we identified the importance, and this is work down at the hatchery. Like I mentioned, Bill came on and he was able to bring some of that research down to the hatchery. And so we were able to identify the importance of surface water at specific life stages during hatchery rearing, which actually increased returns to the river. And so through this result, we were able to modify water management and infrastructure at the hatchery to increase the use of surface water. So hopefully, as we develop these fish, we're providing a better product that will come back to the rivers. We also contributed to the work going on within the basin to help identify the impact of that 2003 alewife invasion that I mentioned earlier. And we were able to relate that to what we were seeing in low reproduction and low recruitment to the fishery, and that was the thiamine deficiency complex. And so this triggered additional work into TDC in the Lake Champlain Basin. Next up. We also saw that if we were able to move adults to quality spawning habitat, we would actually see them spawn. And so this was documented in both the Boquet River and the Winooski River, with the first time having successful reproduction in those two rivers in 100 and 150 years. So that was really exciting, right? Like, if these fish can get to the habitat, they will spawn and they will reproduce. Additionally, our telemetry studies helped to inform how to move forward with restoration projects, but also we can use it in the evaluation of FERC studies and FERC license projects. As you know, there's a variety, within the Lake Champlain Basin, there are a number of hydropower facilities that are FERC licensed facilities, and many of them are going under relicensing. And so we were able to contribute information to that relicensing process to help develop new strategies or management, but also whether or not those facilities are actually working like they should. And so in this case, we were able to identify that there was an issue with the bypass structure, and we were able to get the 619 dam on the Winooski River to be modified. Dave will speak to some of the work that has been done before, but dam removals led by that habitat program in the Boquet watershed particularly has opened up passage, and we were able to identify spawning upstream of Willsboro Cascade where the Willsboro Dam was removed. And then additionally, our telemetry projects suggest that the passage at Willsboro Cascade may be flow dependent. And so this is another opportunity that I don't know if Dave's going to speak to today, but we are working with partners and trying to gather more information about the channel morphology at that location to help inform how we can proceed with management. And also recognizing that it could potentially be not only an issue for salmon, but it could also provide passage for lamprey, which is something that we don't want either. So this can inform both management for landlocked Atlantic salmon, but also sea lamprey as well. It sounds like Dave will speak to that in a bit. So I mentioned that our early results triggered some additional work on thiamine deficiency complex, and so we were able to get a better understanding of the lethal and sublethal effects of adults and juvenile salmon. And so our studies showed that there was some significant results, and one important result was led by Avril Harder and her PhD work, was the ability to identify differentially expressed genes to known physiological effects of TDC. So basically recognizing that these fish have some plasticity and that they're able to have the potential for adaptive genes with a strong association with among family survival. So meaning all that genetic jargon, meaning that there is the ability for these fish to adapt and be able to survive in a low thiamine tolerant or in a low thiamine environment. So this led to the development of an experimental broodstock. Basically, in a way, we're taking selective breeding approaches. It's not selective breeding per se, but we're taking these approaches used in selective breeding to potentially develop a brood stock that are able to be to survive in a low thyme intolerant environment. In a low thyme environment. So that led to what we're now doing, which is releasing this experimental brood stock and trying to evaluate whether or not they survive, have higher survival than those fish that are I guess, baseline fish or our control fish, which are basically the fish that have been released into the system since the 70s. And so we're doing this through the use of parentage-based tagging. And this methodology is heavily used on the West Coast. PBT is the acronym for it. And you will, if you were to look up Pacific salmon monitoring, you would see PBT being used in many of those monitoring programs and studies. And so it's a genetic monitoring tool. Basically, you can get a genetic tag of the parents. And if you track those parents through spawning and keep the family groups separate, and you collect another fish out in the wild, and you take that genetic sample, you can then relate it back to its parents. So you're able to track fish in various groups through this. You just need to be able to get your hands back on those fish to collect those samples. And you can then test a variety of different things. But we couldn't do this without hard work from our hatcheries, both at White River National Fish Hatchery and Dwight D. Eisenhower National Fish Hatchery. And so basically since 2021, the initial phase was started in 2020, and they've been spawning these fish and keeping them separate and tracking groups for all the releases that we've done. And this also has led to developing of a genetic marker panel that we can use for landlocked Atlantic salmon within the Lake Champlain Basin, which is a big step forward on the genetic side of things. Sure.
So using that, can you tell how many of the salmon are actually reproducing naturally and how many came from the stock?
Yes. Yes, so we'll get there in a second. But so what we've been doing for Lake Champlain, we have 9 PBT groups, which are using the low thyme intolerant is our broodstock, experimental broodstock. And then we have 9 PBT groups, which is max diversity. Basically, that's it's a captive broodstock of the fish that typically are released in Lake Champlain. And so these different PBT groups, we've been doing paired releases at different locations. And particularly for you in the room, we've been doing paired releases here in the Boquet, both for fry and smolts. But we've also been doing paired releases in the Saranac and the Winooski River. We additionally provide fish for Lake Ontario for their restoration efforts as well. And so our performance evaluation is, also goes beyond just looking at whether or not these fish are surviving in the wild. We want to make sure that there isn't other impacts that we're maybe not aware of at the moment, and want to make sure that if we potentially were to move to using this experimental broodstock, that we would be able to understand what other impacts there could be for kind of doing a genetic selection. So Paul will speak to this a little here in the future, but we're wondering whether or not low thyme intolerant fish show survival advantages when they're deprived of dietary thiamine. And then it gets into the things in the wild, like adult returns to the tributaries and fish caught in the fishery, right? Because we have 2 goals. We want fish to return to the rivers, but we also want fish to be caught in the fishery. So we try to get genetic samples, fin samples from both river returns and then fish that are caught in the fishery. We use this genetically marked fish to evaluate other questions, such as stocking strategies, whether or not so another key component to fish returning to rivers are them imprinting to rivers. And so the net pen study on the Saranac, and I don't know if Nicole's going to speak to that later, but that was a big project led by New York DEC and Trout Unlimited. But whether or not fish that are reared in net pens for 3 weeks prior to release have better returns than river releases. And additionally, we're looking at different release locations, different life stages, and then we also have adult outplanting. So we were taking fish that were being held at White River and spawned for 1 season, and then bringing them back and releasing them in the North Branch Boquet. So all these fish we know who their parents are, so we can know whether or not, when we get fish back, whether or not they came from fish from the hatchery or whether or not they're wild fish. Right now, and I guess it wouldn't, right now it's like no matter what, all the parents out there are hatchery fish, so we will know who their parents are. And then eventually in a couple generations, right, we would hope to potentially see those natural fish reproduce on their own without having that hatchery supplementation. And then fisheries input is very important for the second goal. And so there's a need to evaluate the fishery, whether or not they're stocked versus wild contributions, and just overall whether or not anglers are happy, right? Is satisfaction high? Are they catching fish? What are those catch rates? And just overall, what is the effort? So it's really important for us to engage with anglers because they can assist with basin-wide projects. They can also increase information on wild fish, and just also provide an opportunity for us all to become more aware of invasives. So this has been done in multiple ways through the LCI Father's Day Derby, also creel surveys, and angler diary program. So the angler diary program was discontinued in 2018. That was partly because of a lack of participation, but also because the agencies were receiving incomplete data. And so that led to an inability to analyze the data and also provided some constraints with data entry. But angler contributions are important. And there was an interest from the angling community to restart the program. And so we wanted to develop and sustain a program that was able to provide us the information that we needed, but also provide positive interactions with the angling community and the management agencies. And so we developed an idea of moving forward with the objective to try to get catch rates, information related to stocking strategies, angler satisfaction, and then we want to ensure that we still keep that communication with anglers, and also provides us the opportunity to compare data sets, so the data that the fisheries managers have compared to the anglers. And so we developed a web-based app, and we were hoping that this would streamline the data collection, and we beta tested it in 2023, and we released it at the State of the Lake meeting back in March. And so this requires that anglers download ArcGIS Survey 123. It's an app that you can get at any of your app stores, and then once you have that app downloaded on your phone, you could scan this QR code and get access to the survey. And so you can open it without having an account. There's no need to sign up for anything, but you have access to the survey. And basically, anglers can go out and, seeing that it's on a mobile device, we're hoping that folks would do this while they're out fishing, but it provides the opportunity for anglers to report the catch, and even report if they went out fishing and didn't catch anything, which is critical for understanding that catch rates. And we just ask that anglers create new trips when they're in different parts of the lake, or if they're tributary fishing, fishing in the rivers, if they switch to a different river. And then we just ask that if there's multiple people in a party, that they just provide one entry. So we're really excited to see whether or not this new approach to the Angler Diary app will provide us the information that we're really hoping to get. So lastly, I'm trying to wrap up here. Just want to share a couple things that came out over the last year. Through some of the telemetry work that we did related to the Winooski releases, we identified that a historic stocking location was more likely to be impacted by avian predation. And this just is an image of one of our staff out on Four Brothers Island, where we actually found some tags that were consumed by birds. And then additionally, that bottom graph is just a graph showing our two different locations of where we released fish, and those are bird counts. And so the red dots, which may be hard to see, the red dots are actually when we released the fish, and you can see the counts of birds at that historic location were like over 100. So these birds knew that big trucks coming up to back up by this location were going to be dumping fish. And so we were able to work with our partners to identify a new stocking location, which we used in 2023, and we also used this year. And I think when we were out there doing bird counts, we only counted one bird. So definitely something that is important to our efforts with making sure that we're producing fish and releasing them and they can survive, right? Also appears that angler satisfaction appears to be high, although we were just talking outside and maybe it's not high for everyone. Some people also haven't. So that could be something that we hope to gather through the Angler Diary app. But it seemed like at least in fall and summer of last year and the spring that folks were happy in the lake and in tributaries. And then there was record returns in the Winooski River. 212 fish were encountered at the fish lift, and that was the highest number of fish returning to the Winooski River in 30 years. And this was also seen in one of the tributaries here in New York, the Saranac River. And this is just an estimate based on what we are handling. It's not necessarily the total number of fish. I think there's far more fish than 103 fish that returned to the Saranac River this year, but definitely high in Saranac as well as the Lamoille River. So in the future, we want to continue working up some data sets that we have, focusing on some of the adult telemetry work that we had on the Winooski River, and that's going to help inform a couple of the FERC projects there. We're going to continue evaluating the broodstock, and we're looking to set up some new studies that we'll be talking with talking about with the cooperative this week, or next week, I guess, now that it's Friday. We also want to develop a long-term strategy for the hatcheries within the basin and continue to, when we get some results, so we sent off 3,000 tissue samples to go get analyzed, and so when we get those samples back this fall, we're hoping that we can make some decisions about stocking strategies. And then, of course, we'll continue to assess and restore in-stream habitat, working with Dave's program, and then continue to provide the opportunity to do some monitoring. If there's actually fish passage work that's completed, we could, then go out and see if we can identify reds or fish above those projects once they're completed. So with that, there's a whole bunch of people who have helped this program and helped the work that we do, and just it's a laundry list of people, but they've all provided so much to the program. And I don't know how much time I took and if we have time for questions, but I'll leave you this nice picture of a salmon. Oh, yes, and so Nicole has the way that anglers have been assisting us as well is if they are actually out and fishing, we have these scale envelopes and we ask for folks to take tissue samples, and then they can mail them back to us and they can be added to the collection. Thank you, Nicole. Oh, perfect. Yeah, so that's key because we get that information back and we can then, send it off to get those tissue samples analyzed and figure out where those fish came from. So I feel like that was a lot of information. I was not expecting to go that long, so hopefully you're okay, Dave. Okay, so maybe I can take one question.
I'm curious, you mentioned that the program started in the 70s, or some aspect of it started in the 70s. Is that when the stocking started? And can you give me kind of a summary of what the history of stocking has been, both lake trout and salmon in the area?
So 1972 is when the cooperative was formed, and that's when they really started focusing on stocking both lake trout and salmon. So I believe the numbers haven't changed too much, where it's something around 300,000 smolts are stocked for salmon, and the lake trout number, Nicole, do you know the number of lake trout stocked annually? 23,000, but that started somewhere around the 300,000 as well. And so over time, we're actually seeing natural reproduction for lake trout, so we've been able to make stocking reductions for lake trout. We're not there yet with salmon. Lake trout, salmon, two different species, two different life histories, two different, the lake trout are in the lake, they're long-lived species. Salmon, shorter-lived species, and require that spawning in the tributary streams. So very different fish. But we have seen success with lake trout, and we're still working on salmon, and we hope to eventually get to somewhere where we don't have to provide that stocking. As far as history prior to 70s, I know that both states were stocking anything that was a salmonid. They tried, in the early 1900s, they tried stocking Chinook salmon here. That didn't work. But so it was a variety of different fish that they tried to build a lake fishery with, and none of them really worked out. And so then in the 70s is when they started to really focus on the two native. I believe so. There could have been like a year or two when they had issues at the hatcheries, but it had been consistent since the 70s. But there's many challenges, as I shared. So we are seeing returns now in the rivers, though. So I think we're getting closer to maybe figuring it out, and maybe this experimental broodstock could be one reason why we're getting there. But also we've had great successes with sea lamprey control. Like it's hard. I didn't show the graph that really shows that we've been able, through the 30 years of that program, we've really been able to knock it down, and that we use a wounding rate to kind of assess and monitor sea lamprey. And the wounding rate targets for salmon have actually been met over the last several years, where they're not really met. It's harder to meet them for lake trout because of the fact that they're in the lake for so long. But we're seeing those wounding rate numbers decline, over the last 30 years. And so I think that definitely has something to do with too. That's the sea lamprey control, yep. Yes, through the thiamine deficiency complex. All right, sorry, Dave. I think I went into your time.